Yeah. The function is, yeah, that means we can find the slope of the sigmoid curve at any 2 points. This is the 2 points, any 2 points. So you can find the slope. We have a formula for sigma as usual. Wherever you go, if you just refer the name sigmoid, the same kind of a calculation you will get it. Okay. And then the function is monotonic, but the function's derivative is not. The function of this sigmoid is monotonic. Just do input and then output. But the function's derivative is not. The logistic sigmoid function can cross a neural network to get stuck at the training time. For that, there is the new term. This is called a softmax function. It's a more generalized logistic activation function that is used for multi-class classification. Please note of this. We'll be using a lot of softmax function in future. Okay. There is another terminology for you. Now it is linear, non-linear. In non-linear, we just talked about sigmoid, right? And also in sigmoid also we have, if we have a multi-class classification, that means multi-class output derivation, then you can use the softmax activation function. We will discuss what is softmax. Okay, this is all about the sigmoid. Next one is tan H activation function. So tan H is also like logistic sigmoid, but better. The range of the tan H function is from -1 to 1. The tan H is also sigmoidal. Tan H is nothing different, but it is also like a sigmoid or S-shaped curve. The advantage is that the negative inputs will be mapped strongly negative, and the zero inputs will be mapped near zero in the tan H graph. The function is differentiable. So we will just see while the implementation only, you will be able to visualize what is sigmoid and how does it work, what is tan H and how does it work, right? So based on the problem statement, based on the data set, what we are um, working on. The function is monotonic here too, while its derivative is not monotonic, the same like sigmoid function. The tan H function is mainly used for classification between two classes. Both tan H and logistic sigmoid activation functions are used in feed-forward nets. Okay, tan H and sigmoid both are in feed-forward network. Okay, here is a famous function. It's called rectified linear unit. Okay. This is called as ReLU activation function. Rectified linear unit. What is rectified linear unit? It is the most used activation function in the world right now. That's what I saw. This is a very famous network, neural network activation function. Since it is used in almost all the convolutional neural networks. While we are talking about the CNN, you will learn more about this ReLU. But in ANN, they just implemented because of, okay, we just activated the function. Based on this weightage and other things, we are getting the output. We'll be learning more of ReLU functionalities later algorithms. Okay. So as you can see, the ReLU is half rectified from bottom. It starts from here. And function of z, function of z is 0 when z is less than 0. And function of z is equal to z when z is above or equal to 0. This is the condition. Okay. Range, you can give 0 to infinity. The function and its derivative both are monotonic, right? But the issue is that all the negative values become 0 immediately, which decreases the ability of the model to fit or train from the data properly. So that means any negative input given to the ReLU activation function turns the value into 0 immediately in the graph, which in turn affects the resulting graph by not mapping the negative values property. So whatever the negative value you are giving, it just immediately converted into zero. So it won't take the negative values properly and it won't analyze negative values properly. It just takes its own value and convert it into zero. And from that zero only, it is taken into consideration for the analysis. So that is one disadvantage in ReLU, but still it is a very, very famous uh, you know, um, activation function in the neural network. Okay. How back propagation works. So this is where we'll just see one thing and then we'll come back to this. Yeah. We'll, I will share this link to you. It might look very simple for you this time, but slowly you can share in chat and take that and store it in your browser for the future purposes. Right. Okay. This is the, I mean, playground is nothing but you can check along with the data. You also give input to this neural network. This is directly from TensorFlow. So why this playground is we are trying to how we are trying to understand any neural network, especially ANN, how it is working. Okay, let's. This is an epoch. Now you know about the epoch. Epoch is nothing but the iterations. Okay, so still we need to learn about learning rate. That is one concept is there. Learning rate. Now you know about the ReLU, Tanh, Sigmoid, and linear too. I think four activation functions you know, right? And then if you want, you can regularization L1 and L2. We'll see. And regularization rate, so you can change something. And then the problem type might be a classification or might be a regression. Okay, so what is this? They have given some features. Okay. Which properties do you want to feed in? Whatever the information which you are feeding in to your neurons, I mean, these are all the hidden layers. This is a four neurons. This is a two again. The second hidden layer is a two neuron, and how the output and what would be the total loss function, and how would be the training loss. Based on that, we will be getting the output. Okay. So you can just, in your free time, you can just read all these things, and how it is. You'll be able to get the code for this information from GitHub, right? So you can just work on. Okay. So I just start this iteration process. Which data set do you want to use? Maybe I can change right there. This is the data set I want to use. These are the pre-trained model, right? Let me see how this changes. Ah, I want this. I have never done this. Okay. I want this. I want to select this data, and now I can go with the first linear and classification or regression. Let it be regression because linear is more of. Okay. If I just change the regression, the data set automatically will change. Okay. I start the just see the flow, see the iteration, how long it is just going, right? You see the output, how it is changing. And maybe, you can also alter this and give more input features. Maybe I can reduce this, but that is your thing. One neurons, but we couldn't find out the differentiation. And even you can add more equivalent. Yes, here also four neurons, and here also four neurons. Now I just started, it's going on. It is around 150, 160, 170, 200 iterations. It's Very fast it is running. Let's see how long it will run. It's optimizing. Okay, it is optimizing. I think it will just go on until you stop, I guess. Let's see until 1000 and then we start. It's going on now. See, if you see over here in this output, I just given the epoch 120. 120, it is like, the 120 epochs, I mean 120 iteration, it take at least 1 minute or 2 minutes to run this. Just see the fast, how speed it is, how fast it is, trying to capture the information. Right? So these are all the things, you have to know. It is just a mere representation of the neural network. Um, it is I mean, how we are feeding the information, how we are putting the information, and also how. So the test loss 0.481, training loss 0.468, and colors we can just change whatever you want, and you can change this regularization. Okay. And likewise, you can go with the Sigmoid and then go with the sandwich. And how this graph just initializes. You
Like
see
the
that.
little graph is showing.
Hmm. Just,
You
just see
see
this.
the flow of the output as an input.
Yes.
Thickness and all, it is changing based on the iterations.
Hmm. So, so you can test it. You can slowly understand because this is the visualization. How we'll be able to understand it, how neural network works. That's what it is. Now it is ReLU. So if you see the ReLU loss is is getting reduced. You see the now see it's standard now. 194, 195, 193 is getting down. So loss is that is why if the loss is less, accuracy more. So that is why they are going for a ReLU model. Okay, so you can just read what this all about. What is this neural network is all about?
Can we
How
give the same churning model CSV?
churning
The
one?
CSV,
I'm not
if
sure.
we
Maybe you can.
are
Not sure. Maybe you can just test this. You can download this code. Maybe give the input in the churning model, which the input which you are dealing. Maybe you can download this code. Okay, and then change the input to churning that CSV file, and then try
Hmm.
and let me know whether this works. It should work because this is how it is. Okay. Okay, so that is for your understanding purposes of neural network because we don't have a proper material to understand through visualization. Maybe in um, later point in time, we'll get it because now um, uh, the graphics, the text to video has been increased a lot. Now you'll be able to understand. Still, the exact functionality you won't get, but at least how does it work? How does it getting converted from one input to the hidden layers, and then how the transformation is going on, how we are getting the output, and so on and so forth. So you can test through this code and let me know whether it is working. Right? So that the playground, you can test it. And correct. So the propagation. So yesterday we just seen how does it work. Let's dive into the mathematics part and see the back propagation working with feed forward and feed backward in neural network in depth. Randomly initialize the weights to a small number close to zero, not zero. It's close to zero. So input the first observation of your dataset in the input layer, each feature in one input node. So forward propagation from left to right, the neurons are activated in a way that the impact of each neuron's activation is limited by the weights, propagates the activations until getting the predicted result y. This is the forward thing. And then the compare the predicted result to the actual results, measure the generated error. Back propagation. From left to right, the error is back propagated. Update the weights according to how much they are responsible for the error. The learning rate decides how much we update the weights. What is that learning rate? So the learning rate is a crucial parameter in neural network, right, that controls how much the model's weights are adjusted in response to the error calculated during training. So it determines the step size taken by optimization algorithms like gradient descent during the back propagation process. Gradient descent again, we started off with optimization right now. Okay, so we'll be discussing optimization too very soon. Okay, so without optimization, none of the deep neural network or at least neural network won't work properly. Okay. For that, the basic thing is the learning rate. How you are getting adjusted the weights based on what? Based on error and based on, see, this is the learning rate. So I'm adjusting the weights like anything. Okay, 0.1, 0.3, 1, 3, 10, or 0.00001. I'm just adjusting. This is also, if I adjust, the weight can be adjusted, between this, the transformation. That means if you are giving one input as an image, say for instance, a dog's image, and it is, getting red in this inside the hidden layer. And the ultimate prediction is whether this model has to predict whether it is a dog or what is that image. Okay, yes or no, right? Just to predict. So what I'm doing without learning rate, how it would be, it just reads the image by block. Yesterday I said through matrix kind of a calculation. It just reads and getting trained. Okay. Without learning rate or without adjusting the weight parameter, weight and also learning rate, it is very, very equivalent terminology. Here, adjusting the weight is also called as adjusting the learning rate. Simple. Okay, so don't get too much, how it is. Learning rate is different or weight is different. It is almost equal. If you adjust the learning rate, that means you are adjusting the weight. Okay, so if you are learning rate means what they are referring to. Again, come back to this. It controls how much the model's weights are adjusted in response to the error calculated during training. Suppose my training, I'm giving my photo, dog's photo, and it has to identify. If the training is right, it will calculate it right, and it will predict it right. If the training is very slow, what it will do automatically, right? There is no human intervention, nothing. What it will do? It adjusted towards, already trained informations with respect to the weightage that is called as learning rate. What is happening? Sometimes, um, if we ask people to give the passport size photograph, they will take through mobile. Maybe they will never adjust anything, adjust the color combination. Nothing will do. Just just like that, they will send it. And if you see that photograph and just enter into somewhere else, it never identifies because the size and color and the other things does not match, including the dimensions. Okay, but the ANN, I mean the neural network processes, what it will do is maximum it will try to reduce the, even though it is not, I mean, this is kind of a irregular sizes, it's not being trained properly, but still it is trying to adjust its learning rate, right? Through comparing the existing image in its training course, and then it is trying to match the given image and also the existing image in the training phase. And it is trying to reduce the error while giving the output. Maximum, it is trying to its maximum. If is saying no means I couldn't identify this image means that means your image, whatever the input image you have given, it is worst at condition. That's what you have to infer from this. I think you got the difference between this, how the image has been given to the network and how you are getting the output. Yes, and this is how you have to interpret the information. Right. So understanding the learning rate, it determines this set size, and it is represented by the symbol alpha or sometimes this. I'm not sure about what is this. The learning rate is typically a small positive value, 0.01, 0.001, zero point 0.1. It dictates how quickly or slowly a neural network learns. A small learning rate leads to slow learning, but allows the network to converge more precisely. A large learning rate speeds up the learning process but may cause the model to overshoot the optimal solution, leading to instability or divergence. It's a kind of a overfitting. So we used to say the overfit, underfit in machine learning, right? The in deep learning, that entirely the terminology we never use overfit, underfit. It is really a different kind of a. Through learning rate only, we used to give the name. Okay, how it works? This is the formula, and you can do the updated weight. You can just do the current weight, and that is the difference. And alpha is the learning rate. Okay, so you can just go to example, and it is just all about. That. So repeat the step 1 to step 5, and updates the weights after each observation. And when the whole training set passed the ANN, that makes an epoch, and redo more epoch, and the architecture is fine. Okay, this is the thing. So error is calculated using class entropy. This is the input. The H1 is ReLU, H2 is Sigmoid, and the output, whatever you are getting, using softmax. So we'll see softmax because ANN we are not using softmax, so I don't want to touch right now. That's a bigger concept. When we are using CNN, we'll be using that. Okay. How does this work? The actual inputs and input, actual outputs, and how it is getting. Mostly all the the representation will be on a matrix level. Okay, and feed forward neural network. How does it different from this matrix? And the ReLU operation layer. Actually, this article is one of the best articles. This researcher is doing a lot of things on real time, and Yeah, by propagating the error minus hidden layer 2 minus output layer of weights. And how does it work and how it is giving you a lot of calculations. Don't worry about this. This is what they are trying to say. I mean, trying to give understanding the brain structure through mathematics. That's what it is. Okay. So you can also check out in this. This is a practical approach. This is where the churn modeling problem comes in. This is what we are using. Now, using this data set, we have a data set. You can just go and implement it. I think all the things we have, whatever we have done, we have implemented. Standardization, normalization, and yeah. So as of now, this is the thing, and maybe until next week. I mean, if we start the next week class, just try running before coming to this, and try get the problem statement. And with this problem statement, what is the solution you are going to give to your to this problem statement? Maybe that is a homework for you. Just test it. Maybe adjust the epochs, maybe 120, 150, 130, whatever it is. And then let me know where it comes to the standard accuracy. And also look at the loss function, right? So we have seen all the required information with respect to artificial neural network algorithm. We just started. That's it. We have to go at least just a long way in our deep neural network. So this is the starting point. Okay. So I'm just leaving it up to you how you are going to run the churn modeling data set and what is your interpretation through each step and get me the idea. So we already discussed about the cross entropy in one of the basic machine learning model. We'll just see how this cross entropy is differs from basic machine learning and this deep neural network. How we will be able to interpret this. Is that fine? So because we have to work and you have to adjust and you have to um, visually see how this neural network started working. Okay, and then slowly we'll be going and dealing with the CNN. From the CNN model, I will ask you to develop a CNN proper model or at least a project, and I will show you one sample project for you, and then from that you will be able to do your own CNN. Okay, so that is the idea.
Okay, Sini.
Any questions aside?
No, I'm good.
Okay, so just hereafter it will be like very fast, and ANN or whatever the concepts we have seen so far, it will get continued to the entire process of neural network. So that is why I took long time to understand ANN. So going forward will be very easy. The implementation and everything will be very easy. And also you'll be seeing a lot of other things as well. Lot of other things means interesting thing, the implementation, how the real-time application works. What are the products and projects we are in front of us, it is available based on CNN model, based on ANN model, and how we will be able to develop. There are so many platforms that are available. They are giving open source model, but to some extent, we'll be able to use it. Hmm? Okay. So with this, maybe I can stop for today's session and then we will continue from next week. Okay.
Okay, Sini. Yeah.
Thank you so much and
Thank you.
thank you.
You know,
Yeah.